they haven't updated it to work with Retina. It's hilarious. It captures an area the size of your current screen on the real 2880 display. So it's impossible to really predict where, what you're going to actually be recording. But no, this works great. The one thing I wish is it doesn't seem to be able to record to any codec other than H.264. So when I was doing something screen capturing for a video, I would usually capture to ProRes. Anyway, so here is this. And the effect is time displacement. And it's not clear, but probably clear what's going on. This takes a grayscale map and then time remaps the frame piecemeal, where black is the beginning of the clip and white is the end. I think you might be able to invert that. Meaning you can scroll through the clip in pieces. So let me just make in Photoshop, this is a 1920 by 1080 image. Make a gradient. There's our fill bucket. You change the order of these in every. Yeah, it moves around. No. There we go. You can just double click on the project window and that brings you the file import box. And then I'm using Command Option F to snap this to the into position of the comp. You don't need, when there's a lot of effects in After Effects that require you to have some layer in the comp somewhere, but it doesn't need to be visible, right? You just need to be able to choose it from here. So here we have a 1 second delay, right? Trying to get the guy on the bicycle to go by, so you can see that.
Isn't this kind of similar to Warp?
No, well, it can be if the clip is similar. Where this is mostly similar. But what this is actually doing is moving in time. So if you have a clip that's very different from beginning to end.
And it's affecting at the gray values and not at the white and black values?
Yeah, well, everything. Like one is the end, one is the beginning, and then like 127 gray would be the middle. Well, and you can choose the range. This is not the middle of the whole clip. This is the middle of 4 seconds.
And why is it warped?
Well, because here it warps because we have a we're shooting a scene, we're looking at a scene with a shaky camera. So we're seeing this change in space. If we had, say, movies. Here's something that changes drastically. It's very old, 1994 computer animation by me. So here's this, and let's do this again. Effect, time displacement. Now this stuff that's stationary is barely affected, but if we turn up, see, this is an MP4. It's starting to have issues as they do.
MP4 still have issues?
Yeah, in general, you want to avoid H.264. Up here, no.
It is very nice. Do not use H.264.
Well,
Is this a time thing, or are you saying that?
it's mainly because H.264 uses intra-frame and inter-frame compression, which remember we talked about this, and all of this annoying stuff that I've mentioned. It's mostly because it's just things that come back to haunt you in video production. So essentially, inter-frame. There's no free lunch, right? Like there's a reason H.264 can get files that look so nice, relatively, so small. That's because it's throwing away frames and pieces of frames. Our production codecs, your lossless ones like PNG and animation, your lossy ones like ProRes and DNX HD and PhotoJPEG, or DV, if you remember that. Use only intra-frame compression, they only compress within a frame. So every frame is intact, right? If you have 30 frames, if you start out with 30 frames lossless, you have 30 frames at the end, even if the contents of each is slightly compressed. Inter-frame compression means you're throwing away pieces of frames, and when you have effects that act on frames, like time displacement, you can get weird results. This here is ProRes. Now, you'll prove me wrong. Try this out. I mean, the conservative thing is to just avoid using H.264 in production. If you shoot some stuff on one of those great 5D cameras, I just learned you have like a ton of 5D cameras. That's really cool. Then if you shoot some stuff, convert it to ProRes, do anything you want to do with it, render out your finished lossless master if you really care about it, or your slightly lossy submaster, your ProRes file. Then convert that into H.264 and show it around. Meaning during production, all intra-frame codec, all not H.264. But prove me wrong, loads of people ignore it these days, and computers are fast enough, and programs are forgiving enough that maybe, at some point this will just become obsolete advice. I don't think we're there yet. But go ahead, I think most people are doing this, are doing this anyway.
If you get it from a 5D, and you're doing, that's usually a data rate high enough that if there is an artifact that happens, you're not going to see it. But if you're getting material from the internet or some other source, or from a crappy camera, or from your phone, chances are it's going to break up when you're doing some sort of effect on it. Because it doesn't have that information to do the effect.
Yeah. I'm trying to find.
Change it though, like in FHD, but even though it just repeat frames and stuff, but it would make it run a little bit slower.
You can use anything also as a source of grayscale. Remember the motion sketch? Where is that? There we go. And now look how this, just as a review, look how this triangle is slightly off the center of the motion sketch path. I need to adjust its anchor point. And then, does anyone remember what I used to make it curve and actually follow the paths? Yeah. That's, this is hiding. Auto orient. Oh, come on, where is this? There we go. Orient along path. And of course, you can modify that. And then I'm going to say effect blur. Fast blur is often just as good as Gaussian blur, and if you're doing a lot of complex stuff, it can add up, like save time. So let's see. With some of these effects, you can't always throw a new comp in there and have it. Yeah. So now I have a small circle of that is 1 second behind. You could also, so that's what's cool. It's not putting a gradient over this. It's using moving footage and turning it into grayscale. One classic use of this, like I saw a student film a few years ago, whereas just after the Kinect came out, someone shot a time-lapse day, sunrise to sunset, and then walked around with their silhouette on the Kinect. So when they came close, it was night, and then when they went back, it was day within their silhouette because they were using that.
That's Toby.
Yeah?
Yeah.
Oh, yeah? Oh, cool.
And he did it out here. It was really awesome.
Oh, right. In real time, or?
Real time.
Oh, nice. So that would have been a little different. That would have been basically reproducing this, right? Like using the grayscale values
maybe
to.
That's what he did. Where you can walk in and out on the Kinect, and then it would
Right.
show back and forth. in the video.
Yeah, I think this must have been the same thing that I said. He must have taken this to Pittsburgh last fall, Art and Code, and showed this because that's where I saw it. And I saw it as a video clip and assumed it was done offline, or rather, I'm sorry, non-real time, something like this. So yeah, you could build the same thing in processing if you had an array of frames, and then for each gray pixel, that decides where you go in the array. Does that make sense?
Yeah.
Grayscale mapping is a enormously powerful tool. Like it's just that's a wonderful way of deciding where things should go and what should happen when, is just draw a map. Because it's very easy in processing to say, okay, we have these values 0 to 55. Where in the range of values, does this go? That's the draw grid application, actually, that is linked here. That's what it lets you break down any grayscale image to a bunch of particle shapes. So that's using a grayscale map and image as your basis for that. So I want to go download Osculator from here for this. So we're going to spend a little more time looking at OSC. Once again, show of hands, how many people have already worked with this? Okay, a couple. This is a huge opportunity to expand what kind of stuff you can use to control your computers in general and record data for animations. For instance, before you could use the Kinect, skeletons in the Kinect with processing. There used to be a thing called Osculator. It's still around. I think it'll crash these days if I try to run it. It's sort of an abandoned project. But it was an early attempt, standalone program, this terminal program, that would capture a Kinect skeleton and spit data out over OSC, the joints. So my Kinect to Pin program, before it ever worked with the Kinect directly using Simple Open and I, that's what this OSC button is for, right? So you can run a separate program and send joints in. But you can use much more than just, it's useful for much more than talking to the Kinect. You can send things between two computers on a network. You can send things now, there's this thing called Node.js, which I'm just beginning to dabble in. Does anyone work with that? Yeah? Node.js is a way to basically run a server in JavaScript, and you can send OSC into and out of it. Meaning this would be a way to puppeteer something out on a network outside here, right? You could remotely control something, Kinect skeleton, by sending those joint coordinates through the web. You puppeteer something in a web browser. I'm just sort of now working on how this would go. But OSC is really, really cool, and probably you'll once you figure out how to use it, if you haven't yet, you'll find ways to apply it all over the place. So if you want to download, and it's linked right here, Osculator. So this is a program that displays OSC communication and lets you reroute it. Lets you reroute it to your mouse, to MIDI if you're using anything driven by MIDI, or to another OSC channel. And remember, we had, I think last time on the wiki here, you need a port, and you need an address, IP address, and you need a channel. Right? The IP address is the machine you're talking to. Usually, when you're starting out, it will just be localhost. Like this is This is always the IP address for the computer you're using right now, 127.0.0.1. This is the day 5 wiki. Then a port number is, you need one of these per each connection. Right, so IP address per machine, each machine needs one. If you were just working on one machine, 127.0.0.1. Port number, you need, is per connection. So if program A is talking to program B, they need to agree on a port number. Program B is talking to program C, they need a port number, a different one. And this is just an arbitrary 4-digit number you make up. It can be anything as long as they agree. And it's not being used by something else. And then finally you need a channel name. Channel is kind of confusing, I think, because remembering that OSC was originally supposed to be a successor to MIDI, I think they were thinking of MIDI channels, like, oh, MIDI has 16 channels, data comes along these channels. Really, it's more like a variable name. It needs to be a string, a name, anything you want. For instance, each axis of a controller, you could have a separate channel. You can also, let's say, and you can put, float, integer, string, Boolean, and I think other stuff. But there's your basic 4 options. You can carry different data types, just like you do in processing. You can also pack arrays into one channel. So if you wanted, you could send 3 floats for X, Y, Z. Or it can often be simpler to just have 3 channels. So I have got, and let me put this up and link it. Isn't it? A basic OSC demo to kind of begin to. Where's ITP? Is everyone comfortable with GitHub by this point? Should we go over how this works? Does everyone understand what I'm doing?
Yeah, if you could just walk us through it once.
Did you guys see Steve Fleiss's tutorial yet? That is essential.
Okay, where is it?
I'll send it to
Thank
you.
you.
Yeah, you send it to all class.
And I'll put it in.
These are these little OSX data files that kind of infest everything. You don't want to upload those to GitHub. Essentially what this does, right, and this is so much easier than when you had to use the command line, because now you really don't. This is really, we'd have to devote, this is like a whole day you could spend on the intricacies of this, and I don't really understand a lot of the version control, a lot of the fancier features. Essentially, GitHub allows you to sync between a local folder on your computer and what they call a repository. So in a way, in its simplest form, it's like Dropbox, right? It's you sync code with a repository on a server somewhere. I think you're limited to like 1 gig each. If it's public, it's free. If it's private, I think they now let you have a few private ones for free, but over 3 or something, you have to pay. So the other people working on commercial projects that they want to keep private, they pay GitHub, and then if you're working on an open source project, it's free. But unlike Dropbox, first of all, every upload of yours is backed up. So when you when you resync it, it doesn't erase what used to be there. It backs it up. You can revisit your backups. So you're not just backing up your project the way it is now. You're backing up every time you sync. So it's first of all a backup strategy, and then it lets you easily publish and share it, and you run this little utility, GitHub app, where it shows you all your repositories and lets you sync with these folders on your hard drive. But the big feature here is that people you can friend and star things to find and bring back, and you can copy the open source projects, fork them. You can make your own copy and then continue to work on it yourself, while always connecting it to the original. And where this becomes really powerful, if you're looking for a particular problem you want solved, you can look at all of the variants of something on GitHub, and you can see who has starred something the most. Like essentially, you have a community rating of the best answer for whatever. So how many of you have tooled around open processing? Anybody? So this is basically a demo site. They often use this in classes. It's really worth bopping around and getting some ideas. I found lots of good stuff here. If you haven't, it's really funny how I would have thought like ITP would totally own this.
No,
Yeah.
we do.
love it.
Okay, yeah, neat.
That's it.
it's just a sleepy day. Okay.
You take the part you need.
Yeah, because it's a really a great resource. Just for those of you who haven't seen it.
But that's the first time I've ever heard someone make the analogy of GitHub being open processing for all.
Yeah, but it ends up being my experience using GitHub versus using open processing. You go to open processing to find visuals, essentially. Like you see something that looks nice and like, oh wow, how do I do that? Then you copy the code and you start messing around with it. You go to GitHub more to solve problems, and that's what makes it's more advanced because you have to have some experience programming before you can start to think, okay, here's my problem. Maybe this would solve it. Like, I'm actually working on this Node.js thing right now, which I have gotten to this very primitive state after a lot of farting around on GitHub and asking people at iBeam who are much more experienced JavaScript programmers. Where is this? There we go. And yeah, this we won't get into today, but if you have some interest. So here this is sending out random OSC values. Remember that CD space drag to folder? That is priceless. You don't have to CD change. Okay, so this is sending OSC to itself. This is the test script. There's a sender and a receiver. It's sending. Here it is. It's packed up. Your array in OSC in your channel, it doesn't have to be all of one type of data. So here's a string, here's a float, here's an integer, some booleans, null, undefined. It's just sending. This is the tester is just sending random data. One terminal session to another. Pretty boring. But this is the nugget on which I'm going to be, hopefully within a week or two, sending Puppet data over the web and controlling things. That's, so, anyway, but I found this on GitHub after I knew I wanted to send OSC data over the web. I knew that Node.js was a way to do this. I knew that someone has done this before. Then I tried half a dozen different solutions by different people on GitHub, most of which were broken, because most of the stuff people put up on GitHub is broken, right? Because the idea is you get it up there while you're working on it, people can see it. And then if you're lucky, which has been my experience a few times, someone will share your interests and pick it up and finish it. That's where the forking and the collaboration aspects really really come into play. Although you don't have to. Like when Victoria and I met through GitHub and finished the motion capture project, we didn't really understand how the forking thing works. So we just downloaded copies and edited them. You don't have to understand the more sophisticated things. And really, all that kind of collaboration stuff is meant for more than two people. Because really, two people, you can just work on stuff, and you can, if you've ever done collaborations, you can rename versions with an underscore in your initials. Two people can pass files back and forth and work on them pretty easily. It's when you get more people that solution doesn't scale, and then stuff like this becomes really valuable. Anyway, so something a little more interesting. Wiimote needs to be, so for those who haven't done this, Osculator costs money. The demo runs, I think it will run for like 30 minutes and time out or something. So for most of what you might be doing in this class, it will probably be great to use the free version. If you're performing, you definitely want it's like $30 or something. It's really useful because not only can you, so this is pairing over Bluetooth. Press the red button inside your Wiimote. Running.
We have
Should we love the parent Bluetooth?
Yeah, Bluetooth sucks. Let's just, I was going to use this guy here, but let's see if it's a battery charge issue.
I put the GitHub in the that's recorded.
Oh, cool, thanks. This doesn't work at all. No, it's backwards.
And what he was using is the Apple app. I don't know if everyone's seen that before. But GitHub, usually you do it through the terminal. And it's really good to do it that way. Because it's harder to run on. There's also, if you just don't want it to do it, that there's a standalone Mac app. And that lets you upload your versions to your account.
Mm-hmm.
It's nice and quick. But the tutorials talk about it in that. They have to go to the site, check out the instructions.
Yeah, I find the all command line GitHub kind of terrifying.
It's very exciting.
Well, because to me, like, there's really like two types of ways of interacting with terminal. There's like ones where you use like kind of simple little particles in understandable ways, like move a bunch of files. Like if you've accidentally rendered 1,000 ping images to your desktop, and then you type, nv space * dot ping, and then the name of the folder you want to move them to. And that's kind of long, but every piece of that is understandable. Move command, all of this file with this extension destination. Versus something like GitHub, it's more like being a wizard, right? You're reciting these strings of commands that, I mean, once you learn what they are, what they do, and what they do in combination, I'm sure it makes a lot more sense. But if you come to it cold, I mean, push -u origin master. I mean, okay. So now this is receiving this, and this will work with any human interface device, right? This will work with joysticks. This can work with Wacom tablets. We tried to plug that in last time. So what you do here is you turn on OSC routing. Let's do pitch here. And I love these names. Pitch, roll, yaw. I mean, it would have been nicer if they had called it XYZ. But then again, not everyone agrees on what X, Y, and Z are if we have free access. Anyway, yeah, like roll should be...
It's like in aviation. Pitch, roll, and yaw are
Right.
pitch.
Pitch, roll, and then...
Yaw is this way.
Okay. So you can fly your remote. And then here you would specify a port. Remember that localhost and 1.7001 are the same. And let's say, oops. Oh. And then here you might want to send this to a channel. So to send. So this will take, close. So this will take the pitch, y-axis data from the Wiimote, and spit it out on this computer, right? IP address is your machine. On port 555, that means 555. That means the other piece of software you want to control has to be listening on port 5555. In a channel named foo, and then that means, what did you say?
What is this term?
Channel is, let's say, OSC terminology. I think it's a dumb name. They call it channel. They're really variables, as far as I can tell. Right? I mean, it's how we would put this. I mean, it's going to be a floating point number to 0 to 1. Like I said, although OSC can carry any kind, it can carry strings, it can carry floats, it can carry ints, it can carry booleans, most often what people do, the convention that I see most often, is people turn everything into floats 0 to 1. In fact, I think there are some programs whose implementation of OSC is really limited, and that's all they understand. And then you turn it into, right? If you want a true false, you say if it's 0 or is it 1. If it is a pixel amount, you multiply the 0, point whatever by the width of your screen to get the right pixel value. You kind of do whatever transformations you need after to get it where you need. But often it's just float 0 to 1. I think that's what we're dealing with here. It's going to be. But let's take a moment. What I was doing with GitHub was syncing up, and I think I've been kind of splitting my code between FTPing it and putting it in GitHub. I'll put everything into the GitHub thing. I just put this OSC demo 1, so you can go get this. But let me move to where I have it on my hard drive here. So I made, after seeing what shape all my OSC examples were in yesterday, where I have one talk to a Wiimote that I'll put up in a second, which is actually really useful because I had to go through and figure out what all the channel names are and what the whatever. One for talking to Wiimote. But that's a lot to hit at once. So here is a very basic OSC demo, which is based on the ones that chips with the OSC library itself, but it's made a little more simple, I think, a little easier to understand. Right, so here is this. Here is a program that both sends and receives. I mean, what to do, right? Except this is not just within processing, lighting up the red square when I click the green circle, which would be trivial. It's sending an OSC message, and it's listening and it's receiving it. So what I'm going to do here to demonstrate what we're on about is, I forgot, this beta of processing. Does anyone remember when processing used to do this, like around version 1? When you would go to the file, it would try to list all your sketches and crash? Fun. That bug has come back. So yeah, on processing 2 beta 3, I have to remember to only use the file open and not go up to... I'm sure they'll fix it in beta 4. It's really fast. How many of you are on processing 2? Show of hands. Okay. It's really fast. Like all the crankiness, I find is totally worth it. Like, do you also find it a lot faster?
Yeah.
But yeah, it has some bugs. Okay, so what I was trying to do, I think I'm just saying Command E, is export application. Because I want 2 instances of this running, so you can see what. Right, so here I export an application. Here's the one I compiled just from the thing. And look at that. Here is the original sketch. I click, but I click this one, and it lights up this one instead of this one. That's because, like I said before, your ports have to be, your port numbers are a connection between 2 programs and only 2. If I wanted to connect the output of this to here, I would need to create another set of port numbers. In fact, what is it? Yeah. All in one pair, right? Like out and in. I'm pretty sure. Unless there's a way around that. That's been my experience anyway, that you need. One thing that we haven't gotten into, which might be interesting, have you noticed that like I have these little text files with some of my apps? If you download some of the things that I've made that have been distributed, I have these settings files. And then you can change these settings and actually affect the settings of a compiled app. This is really useful. I mean, I'm sure someone has thought of a much more elegant way to do this. But this is in Connect to Pin. It's probably an easy place to get it to see how it works. This is on GitHub. But if you pick this apart, there's a lot of useful things. Like, do you guys use Control P5 for buttons? Like generally, do you do? Yeah. Processing has some built-in classes for buttons and sliders and things called Control P5. I didn't know that when I made my own button and slider classes, so out of spite, I keep using mine. But there are some, for what it's worth, there are some interesting little widgets often in these apps I've made. A countdown if you need a sync beep. This is like your classic count down from 8, beep on 2, like leader. But what I'm getting at is here. I've made, using that all-powerful, Marius Watson's all-powerful data class, which all this is really doing is simplifying the ways that processing works with text. It is, and you can copy this and see how it works. It's just looking in that text file for a string, and then looking at what's after it, and then turning that string into a float or an int or a Boolean or string. Color is really weirdly complicated. And basically you can control settings in an app you already compiled, right? Because normally you can't go back into the code and change things. That's the sort of thing. And so yeah, you can just take this and build this and use your own. Right? I'm setting variables in my program based on, and what's nice is that it also gives you defaults. So if it can't find the settings file for some reason, it just uses the defaults. That's the sort of thing, and you notice that since Connected Pin itself receives OSC, that's a great thing to leave in your settings, is OSC IP numbers and ports. This only receives, but if I was receiving and sending, you'd want to receive and send. Then you could run multiple instances maybe of a program if you wanted to, if you really wanted to light up multiple red squares. You could set multiple ports, right? And if we're running it all on the same machine, this would all be 127.0.0.1. So, like from here, you can start to branch out, right? You have this, we're listening on channel name foo, receiving on port 9000. Let's not send anything. Let's make this a different port. And let's go into oscillator and go back to that routing. Rather confusingly, you have to go to new in order to get to this menu, which is annoying. But and let's make this localhost 9000. So now we're sending it to 9000, channel foo. And when you send OSC, you have to, as usual, build a function, right? Because it's probably worth going over the steps here, right? You need a setup function. This initializes the receiving function and receiving part and the sending part. So that needs to go in your setup. And this receiving, it runs automatically afterward. Is triggered by receiving an OSC message. You don't actually need to check for this in your draw loop every frame. And usually I put this into an array. So I can, sending you do have to put into a function here, and that goes in your draw loop. And so this is all this is all here and numbered. And then finally, I add something called OSC use, where I print out. Well, here it's just printing it out. But here I do something with the data that I've put into this array.
In this case, it's just receiving 0 or 1.
Mm-hmm. Yep. Originally, I send 0 or 1 here, exactly with the mouse pressed.
And what if you want the exact position to do the
Well, there, let's get rid of this. And we're sending stuff here. Oh, I didn't use there we go. So now my y-axis is, and let's say, let's do that, so equals 1 is kind of is greater than 0, 0.5, let's say. And once again, it's a relative change, right? Once I move it, it forgets, just like a mouse, right? That's the trade-off with the Wiimote. You can have relative motion in 3 dimensions or absolute motion in 1. So let's see if you can put this somewhere we can see. Unlike a Kinect, my experience is it's pretty flexible. One really cute thing about the Wiimote about Osculator, is that it just begins to add parameters as it detects them on your interface device. If I were to hook up a Wacom tablet right now, for some reason the Bamboos weren't working last time, and I didn't bring one. I guess Intuos and Bamboo are the two current. They always change the names bizarrely. There was the Graphire for a while.
Yeah.
Whatever. I guess they need separate drivers now. It used to be one Wacom driver worked with all Wacom products. Anyway, if you put in a Wacom tablet and had a driver for it, then it would pop up here: pressure, tilt, buttons, and so on. So here we turn on IRXY. And look, you have here smoothing mode. I don't know what this is. Motion plus. That sounds exciting. Anyway, this IRXY, and there we go. And here is the absolute. Let's actually make this a little more interesting. And give ourselves X, Y, and Z. New. I forget if we can do this all in one go, or if we have to add new ones. Let's see. And like I said, you could pack this all into one array. In fact, Osculator lets you do that. Like there, you can split an incoming array into, like, if your device sends out things in an array and you want to split them, you can do that. I think they call it multiplexing. It's in here somewhere. Yeah, if you dig down in the menus, you can split an array into individual channels, or you can merge a bunch of incoming stuff into one. But for now, let's just, Y, X, and Z. And you can save these configuration files and pass them around. Like, consider it, the Windows equivalent is GlovePy. I'm not sure what you'd use in Linux. It's a similar program. The interface I find a bit more confusing. It is free. Anyway, so now we have the stuff coming in over X and Y. So let's get a P vector here. Or actually, no, let's just keep using this array that we've got here. And notice that I already have this receive function that is based on the length of that array. So as I add elements to it, where is it here? As I add elements, it just keeps on going. Position X, position Y, position Z. Now mostly you'll be working with receiving data for this purpose, right? Because we're going to, if you end up want to control things in animation, you mostly want to be taking data in from some peripheral, and then bringing it into processing, saving it out in some kind of text format, and then bringing it into your animation program. Right? So that's most often we're working with the receiving. And I have an example prepared to show you how you can generate an After Effects script from this. So, what do we want next? We're looking at this. Let's just actually say, let's start with the diagnostic here. X. Do all of you do this routinely? Oops, not send data. Like use a print line or whatever console thing you do for whatever you're programming to, to help you figure out what's going on. Oh, thanks. 5-4E, accept. So here, this should give us our 3 positions. And I've got this guy. If you get this particular brand, like you can get Nintendo's and it's more expensive. This is Nyko, some generic one. Just so you don't get burned by this. There's a switch on the back that says timer 1 hour, 2 hours off. If you switch it to off, it doesn't turn the device off. It turns the timer off, which means it'll run in your backpack until the battery runs out. It actually runs it's just running a bunch of infrared LEDs, so it actually runs a really long time. But you want to like leave it on timer 1 hour. It's stupid, but you know it's cheaper than Nintendo's. Anyway, so sure enough, here we go. And this isn't so interesting, so let's just have in. And then we can put this in OSCUs. We could put this, wherever. Let's just say let's start with 2D. Now, what do we need to do this? Because right now it's just a float 0 to 1. We need to multiply it by width. This is a very common trick when a lot of times coming from Flash, I'll use this instead of width and height. This has the advantage of if you need to do some calculations before you've done setup and set your size, because before then it doesn't know what width are. Same thing. And, no. There we go. Now, this is really noisy. Part of this is probably, let's see, this may be due to it fighting because I have this turned on and I have receive IR turned on. Let's turn this off. See if this improves. No. So it's getting us from here. There's a device called the Hydra, which I have but haven't fooled around with yet, made by a company called Razer, R-A-Z-E-R. It's a Wiimote-like device, but it is wired, and it is much more precise. So what I'm about to do here, you can simply turn up the smoothing. And of course, you could write a smoothing function in processing as well.
What's it called? The controller?
Oh, the controller? Yeah, it is called Razer Hydra.
It was insane.
What?
This thing is insane.
Yeah. Oh, the problem is that it has an SDK for OS X, but it's not clear how to get it to send OSC on Mac. It works on Windows. It's clear that it has the capability, but no one seems to know. It's relatively recent. It came out this year, I think, or maybe late last year. I can say that, yeah, it's a lot, despite having to deal with a cable coming out, it's much more accurate. So you have you have a sensor bar like this, or it's a globe, and you have a controller. You get 2 in a pack. It's like 100 for 2 controllers and the sensor. But despite the wire, it is much more accurate. But the question is, how do we use it on a Mac? There's one thing that works with its PCI. So you have this, and you can keep cranking the smoothing up here, which is less than a 0, but get the job done.
You need to do something really fast.
What do you say?
Just do something.
Yeah. You could also probably write something in processing, although that would add some latency, right? You need to add up some samples to smooth. Some of my little apps that I've been showing have a smoothing function built in that was written by Golan Levin that you can copy and paste to need. It's pretty neat, but you need a certain number of samples, stored up in your array to look ahead and behind. So let's try the IR here. So that has its own. Look how it's getting this here, and we're not using the Z at all yet. So actually, let's turn on OSC routing here, and instead of using the built-in accelerometer for relative position, now we're using. Let's turn this off. Oh, I've got them mixed up, the X and the Y. That's odd. Really? Yeah, so it would seem. No, now they're mixed up, so that was interesting. Yeah, I thought they were pretty clearly labeled. Okay, now there's no, you might want to reverse X and Y. Now this is with no smoothing at all. So look how much better this is, right? We needed to turn on a ton of smoothing in Osculator just to get something usable out of the built-in. And look how clean this is. And so what would you do if I wanted to, and I've got this in the way here, if I wanted to reverse the X and Y, reverse the y-axis, we would probably do, right, absolute height minus that. Oops. 1, 2, oh. There we go. So now it's up and down. No smoothing. Well, that's the power of the IR sensor bar, because the accelerometer is just within this. It's just trying to tell whether this is being moved up, down, left, right, forward, back, and it's cheap, right? It's like a $20 toy. When you add the sensor bar, you get the infrared camera in the front of here, and there are so many folks, right, have done some really fun stuff reversing this, because if you do this. Right, because it's just a camera, and of course you need to reverse all your values because here it's.
Does it have to
It does have a line of sight. It's a camera. Running infrared. But what's beautiful about this is that in here are just a bunch of infrared LEDs here and here, meaning you could take this apart or even just build your own infrared LEDs and mount them on a helmet, mount them anywhere. In fact, that's John. Oh, did I turn this on? There we go. Yeah. So that's an option, right? It's much easier to mount a couple LEDs on something than it is to mount this guy. And so this is all coming in, and you can store this, use this in whatever you want. Now, to use this in 3D, what would you do? Let's change this into an ellipse to make this clearer. Everyone knows about this, right? You can choose whether to draw your shapes and processing from the center or from the corner. Depends on how you like thinking. I draw everything from the center. Okay, so we have this, and if we add a z-axis here, we would do something like this. Now, when I work with the z-axis, in addition to width and height, that means we need a depth. I just do it this way to keep track of how I'm working. How you determine the depth, right? Because there's no determined volume. Like you get to decide how big this is. I mean, the Kinect is about 2,000 pixels worth if you're working with the Kinect stuff. However, I find that a lot of that looks really wrong because we're not really working in 3 dimensions. We're working on a screen. Probably someone who's worked more with the nuts and bolts of how the Kinect works could explain the logic behind this. I know that I tend to like to work with a much smaller range of depth to keep things from going way far in the back or way far forward where you can't see them. But if you just use this variable SD, in my writing you'll see often I use SW, SH, SD for source, width, height, depth, and then DW, DH, DD for destination. Like if I'm making something for like an HD project in After Effects, and then it's easy to like divide by one and multiply by the other to translate in a script. Anyway, so here I would get this by saying, oh, except right. Someone tell me if I'm going to move a shape around in processing in 3D, what do I do? Does everyone know what did you say? Okay. Okay. This is good. This is really the first thing you want to check. You want to make sure that you have put processing into its 3D mode. And it used to be in processing 1.5 that you did this with OpenGL. There were a bunch of different renderers to choose from. Now in processing 2, there's only P2D, P3D. So make sure it's in 3D mode. So this is worth, if you've never done this before, you've never moved something around 3D in processing, this is worth paying attention to because it's not terribly intuitive. The first thing you need to do is push matrix and pop matrix. So does anybody tell me what these do?
It's a stack, basically. It's a stack structure, and the matrix keeps a position, well, in X, Y, Z, and a rotation. So it's a 4-dimensional matrix that is saved there.
Okay, hold on a second. I've heard this before. What are the 4 dimensions?
It's rotation.
I don't know this.
Well, no,
yeah.
It's linear algebra. It's a bit that. There's a way, like a shortcut achieved in linear algebra that allows you to keep information about rotations in 3 dimensions and keep the 4th dimension for coordinates in 3 dimensions.
Okay.
So the 4th dimension, and that's called canonical coordinates. Sorry.
So it's a way of what would normally take you 6, right? X, Y, Z position, X, Y, Z rotation, representing it in 4 instead of 6. Okay.
So multiplying these matrices actually allows you to move stuff.
Okay. The practical upshot of this is, you know how every command in processing affects everything below it in the order, right? If you say fill red, then everything after that is going to be red until you. So the command we're about to use in 3D, which is translate, and then XYZ coordinates. The basic way of working in 3D in processing is the shape you want to draw is at 0, 0, 2D, and then you translate it to where you want it to go in 3D. The problem is it translates one of those commands that affects everything below it. So you'd be moving your entire scene to these coordinates. The thing about push matrix and pop matrix, they protect. You can think of them as protecting what you're about to draw, the commands you're about to use, or rather protecting the rest of your scene from the commands you're about to give. So when I say translate within push matrix, pop matrix, it will affect only the ellipse because that's all that's there, right? If I take these away, we'll do that in a second. You can watch it break everything. It may not because it's the last in the list, but you get the idea. So. But this is how you have to work in 3D, as far as I know. Unlike 2D, where you can just say, okay, ellipse at these coordinates, you must do this for each thing you want to draw in 3D. So let's get that z-axis in there, times SD. Let's try something a little more drastic. So what I mean about depth is very much to taste. Unless, I mean, if you're working with real world measurements, okay, now we've gone completely off the scale here. You can also try, because typically with depth, unlike x and y, we're starting in the upper, from your perspective, the upper left corner. With the z-axis, 0 is the middle, and then depending on the program, forward and backward are plus or minus. This is not consistent among programs, whether minus is towards the camera and plus is away, or plus is toward the camera and minus is away. So let's try, 0 to 1, float, times our depth range, minus our depth range divided by 2. So that will give us still not terribly a lot of difference, but what do we have here? Try 500. I'm just trying to make the circle grow and shrink, obviously. There we go. But then again, notice it doesn't stay where it is, because that's relative position. Whereas the right, push it and then it will come back.
Huh.
Right? So yeah, it's not a perfect. I think the Hydra actually you can get absolute movement in 3 dimensions also, so you don't have to work with this hack. In fact, I've heard that. I'll bring this in once I get a demo running. There's a program called Sandy, S-A-N-D-D-E, which is I think free for non-commercial use, but you have to ask them. Oh, I put a couple of blocks in. It's going behind these. That's really cute. It's going behind the 2 rectangles that I drew at 0. That's cute. Okay. Everyone wants to play with this. Pass it around. But so this is basically good thinking. It needs to see. Yeah, right now it needs to see the sensor bar. But this is really a basic overview. I hope this has been new to a lot of you and useful, like how you work with OSC. And this is one of those things that really could potentially be applied in places that are way beyond this class. Right? Any computer with Bluetooth can work with the Wiimote, Wacom, is over USB. Hydra is USB. It really opens up a whole world. All we're going to do as a final step is have this add coordinates, or add its location in every frame to an array list. Does everyone know array lists? Show of hands. Who's used them before? Don't be shy. Okay, so about half. No, about 3/4. Right. Okay, so an array list is an array you can add and subtract from really easily, versus the regular arrays processing, which you have to know how big they are when you begin. So with an array list, it's great when you want to just keep adding things into it, and that's what you do with the AE keys thing. And this, by the way, this process would work pretty much the same, say, if you're using open frameworks. If any of you ever end up still working in Flash, there's a little companion app here called Oscar that will route OSC into a Flash SWIFT. So you can set up this and have this sketch run. I mean, there are more sophisticated things out now if you are into building things in Flash Builder and whatnot. But if any of you are working in Flash in the traditional way, you can just write a SWIFT, an air style SWIFT, and then send OSC into it with this guy. Yeah, I mean, you can do this to move connect joints between computers. You could use this to take advantage of programs like Isadora or Jitter. I'm really into Siphon, using Siphon in combination with these really powerful traditional visual programs like Isadora and Jitter, where you can, do crazy things with OpenGL release. Although some of you are in Patrick Cabron's graphics programming class, that's about change for processing. A lot of the stuff that you needed to go to a separate program for are about are available in processing now. So I'll leave this running for a second. And that's here. And then I'm gonna go take I actually had a fun early process. Do I see if I have this in my movies here? It's not here. There we go.
Save that script.
Sure. Actually, no. Thanks for this. That was more fun than. Oh no, you don't. Let's see if after a minute this recovers. Nice. We'll give this a second. If not, I have a complete. Oh boy. Let's give it a second. The old one used to actually sometimes pull through after a long time indexing your processing directory. Okay. So, oh yeah. Here we have more complete OSC Wiimote test. I'm going to copy this into the GitHub for our class. Hey, I think that worked. Nice. All right. So here's the basic one. I just waited. All it's doing is it's indexing your complete processing files so that you can go like Sketchbook. Oh, yeah. It just earlier versions of processing would freeze as they scanned your whole sketchbook. Yeah, whatever. Fortunately, we had a chance to save this, so it will be. So let's put that in here. And then here is a Wiimote test, which processing will open when it feels like it. And notice that it comes along with a oscillator file, right? Already set up to route to these coordinates. And processing. Hold on a minute. And here I am. Here I'm going to say sync. So now it's uploading whatever I put in that folder to the GitHub file. So you have the basic one, the Wiimote control, and this one will give you the full. Come on, there we go. I think this one is just set up for the. There we go. This one's just set up for the accelerator. So we must be following the red dot. So again, this you can use without the sensor bar. I mean, if you get the smoothing right, what do I have it turned up to? You can save the smoothing with your individual osculator file. Okay, so it's up 3/4. It's pretty good. And look, watch all the buttons as I press them are triggered here, so you can think of things to do with them, right? If this channel equals 1. And as a final step, here I've added, these should look a little familiar, those After Effects key recorder, that data class, and this doesn't even use a Wiimote. This is just really stupid. When you pound on the button, it writes keyframes to go to the lower right corner in After Effects. Oh, you have to press space to start recording.
Is it like a tap sample?
Well, it is recording in time, so it will record those taps. So now, if you look, this guy generated a script. One thing that I should have shown you earlier, actually, if you just want to run a script in After Effects and you don't want to go File, Script, Run, Show your thing, just double-click on the script and this will turn up. This, I find, sucks as an IDE. I much prefer to use like Sublime Text or something. But it does have this cute feature where you can just say After Effects and choose your version number, play, and it will send it to After Effects and run it. Great. It just created that comp. If it's a little easier, I'm going to delete all the time remote stuff and do it again. There we go. And tap, tap, tap. Right? Now, of course, you can combine these. And of
Can you
course,
show the keyframe?
sure. I'm going to turn on motion blur. More interesting. These are keyframes. Now, of course, you can combine these two examples, right, and get something that records Wiimote motion. Or you could have something, say, that uses a Wiimote to drive Yellowtail. Have you guys heard of this? Golan Levin's Yellowtail. I'm going to put this into, where's the example? It is one of the most beautiful drawing examples I've ever seen. If you've, oh, where is it? He made it in sometime in the 90s, I think, and it's been, there it is. It's been translated into all kinds of different languages. And there we go. Paste here. So imagine controlling this with a Wiimote, say. There's even cooler things along these lines called like SuperDraw, but I don't think the author has actually released the source code for that. It's processing app. So in a similar vein. Yeah. I intend to bring this to Patrick's class next Thursday and be like, how did this happen? Okay, so let's take a, oh, before I do that, right here, really quick. This was just something I made a couple years ago when I was starting to learn to use processing, learning how to put stuff into arrays. So this was performed with a Wiimote. So I'm basically just moving the blue dot around through a grid of little orange dots.
Like
involved.
Mm-hmm. And as it moves, really slowly. So this was part of an installation, but all pre-recorded. So this all went into After Effects. Man, YouTube really hasn't quite got the hang of 720p. That's more like it. Also, the flashes you see and stutters. This is on my GitHub. There's a glitch program that I wrote, or no, most of it I borrowed from somewhere, where you corrupt an image, then copy the pixels into a healthy file before saving it. Or rather, because otherwise I won't be able to read it back. So I basically rendered this out as frames and then corrupted some of the frames on purpose and saved them. And then I have a bunch of After Effects effects that gradually go from 0 to 11, as it were. This is all, a lot of this is Video Go, which is this plugin that renders brushstrokes. So basically, it's just a fun thing to do with Illuminate, essentially. Great, so let's take a break, back in 10 minutes.
Sorry, I left the last.
Sure, yeah.
My girlfriend was flown to Israel on a medical emergency.
Oh, it was flown? Oh, that's not good.
Yeah.
Well, if you need to take off, that's...
Pardon?
Yeah, if you need to take off and deal with it.
No, I yesterday. Took her to
Oh,
the
it's
airport,
yesterday. Okay, it's not
but
like
now,
right now. Yeah.
she landed, and
Yep.
and so I had to see that everything's fine.
Yeah, that's good.
So it is. Fortunate.
Good. Yeah.
TechServe, by the way,
Yeah.
was really good advice. They'll have my computer ready in a few days.
Excellent. Oh, you had hard drive trouble, if I recall?
No, the hard drive is fine. It's the GPU overheated.
Huh.
Yeah, because
What were you doing?
I was playing a big preview, but it's a
Oh,
4-year-old Mac.
Oh, man.
Yeah, man, I'm telling you, those like 4 or 5-year-old Macs, if you do enough with the new GPU stuff, you can burn.
Wow.
I wasn't using CUDA or anything. I just
Yeah.
Regular, you know,
Well, then, I know
pixel blending and boom.
Interesting. I mean, I think everybody's something to that. Like, I had, before I got this guy, I had a 2007 MacBook Pro here. Let me stop and upload this.